Hey everyone, today I'm going to start building my actual lunar rover, and I thought the best place to start would be making the wheels and getting closed loop motor control up and working. So before I show you how I build a dual motor control system, I'm going to teach you how you actually power motors in the first place. So the easiest way is to just hook up a battery straight to the motor. This allows the motor to spin at max speed, but it's pretty unsafe since you have no control over the motor, the speed, or the direction. Now, the second method is using a switch to turn it on and off. This can be useful for very simple applications, but you can't control the speed or the direction. With this method, you can switch the direction by actually flipping the polarity of the wires. And in a more complex system, you could digitally switch around the direction the current is going through the motor to control the direction. So great, we can control the direction, but we can't control the speed just yet. To control the speed, we need to use something called pulse width modulation. Imagine you had a computer in the middle between the battery and the motor, and you have a program that turns the motor on for half a second and off for half a second. If you had a program like this, then on average, the motor would spin at 50% speed. Let's say instead of half a second, it was half a millisecond. Now you're powering on and off the motor at a crazy fast speed, but it's still only being powered on 50% of the time, so it'll appear as if it's moving at 50% speed. This is pulse width modulation. You're changing the duration of these pulses of power to get different speeds out of the motor. You can do this for 50%, 75%, 25%, or any range of speeds that you want. To automate this, we're going to use a motor driver, specifically the L298N driver. This motor driver takes 6 digital inputs. It takes 1 for the speed of motor A, 2 for the direction of motor A, 2 for the direction of motor B, and 1 for the speed of motor B. It converts this to PWM signals for both motors at once, and it's also pretty cheap. But where are we going to get the speed and direction info from? Well, I'm going to use an Arduino Nano to actually control the motors. I'm going to write a program that will take commands from my computer via serial USB. Then it's going to convert those commands into digital signals that the motor controller can read and power our motors with. So, this is the system we have now. Our computer is sending commands to the Arduino Nano using serial USB, and it's going to send the info over to the motor controller, which will then take the 12-volt power from the motors and turn that into pulse width modulation signals to make the motor spin. This is what's called an open loop control system. We're spinning the motors, but we don't actually get any feedback from the motors, so we don't know if they're going at the proper speed. This can be problematic because if one motor is spinning too slow, there's no way of adjusting for that. We can fix this using closed loop control. Closed loop control doesn't just take input from the computer, but it's also reading the speed of the motors in real time and adjusting the PWM signal as necessary. If we want closed loop control, we can just take the real-time speed data from the motors and send them back to the Arduino. Then, in the Arduino's program, we can actually have it adjust the PWM as necessary to make sure the motors are going the proper speed. If you're wondering where the closed loop is in closed loop control, it's right there. This basically makes sure the motors are going at the exact speed you want them to. Now that we know what this looks like in theory, I'm going to head down to my garage and show you what this looks like when it's actually built in real life. So I've already built a set of motors, which I wanted to demonstrate before I move on to showing the process of building the other half, because I'm going to have to redo all of this again for the other 2 motors. This is what we have. We have 2 motors, 2 DC motors, connected to a L298N motor controller right here, which is all being wired up to this Arduino Nano. Now, the Arduino Nano is being powered via USB to my computer, and it's actually also sending serial data over the USB. On this side, we have a battery, which connects over to a fuse, and an on-off switch, in case I ever need to turn it off for some reason. And then that just connects over to the to the motor controller. The Arduino is running on 5 volts, so its power source is my computer, versus the motors are running on 12 volts, which is why they're getting powered by a battery. And the motor controller is taking in both of the 5 volt information from the Arduino and the 12 volt power from the battery to control the motors. Now that I've shown you a working demo, I'm gonna start building the other 2 motors and the other Arduino system and get that all to work. Okay guys, so I've officially put together both of our new motors. I have our breadboard, our Arduino Nano, and our motor controller ready to go. In putting this all together, everything is going to center around the motor controller. So I think a good place to start is wiring this up to the power supply. Okay, so I have hooked up the motor controller to the battery. Red is positive, black is ground, as always. When we plug this in, we should see an LED on the motor controller light up. And so I have the switch here, and so if I flick it on, we see an LED light up, and nothing is heating up, which is good. If you plug something in and it starts heating up and you smell smoke, that is bad. Great, okay, we've plugged in our motor controller. That's awesome. So the logical next step is to plug in a motor. We have this plugged in now, but we can't actually run it yet. Reason being, there's nothing telling the motor controller how fast the motor should go. And there's one more reason we can't just run it. If I tried to just run this, it might overheat the motor and break it, because this is a 6-volt motor and this is a 12-volt battery. And the reason I bought a 6-volt motor is, 1, they were cheaper, and 2, I didn't actually realize that they were 6 volts when I bought them. So to actually make sure they don't catch on fire, because as we've seen, I already built it and it worked, the solution is to just max the speed at 50% capacity, at 50% battery, because that's a rough equivalent to 6 volts, which is what this is using, which is a little risky, but from my testing, nothing ever got hot and I never smelled any smoke. And I'm being pretty cautious about the maximum speed I'm letting the motors run at. I'm never pushing it past 40%, which should, in theory, stop them from being absolutely destroyed. Okay, so I want to take a closer look at the actual motor controller itself. So, wow, this flash is really making all the details pop. So, this right here is our 12 volts input, this is our 5 volts input, and this is our ground. Now this is going to connect up to our Arduino because the Arduino is going to have the 5 volts. This is obviously just the power that goes to our motor, so we don't have to worry about that. This is pretty self-explanatory. Now to actually control it, we're going to be using these 6 pins. So these 2 pins control the direction of this motor, and these right 2 pins control the direction of this motor. Now the ones covered here by the jumpers, when you take that jumper off, you expose these 2 new pins. This is what's going to control the PWM, or pulse width modulation, for the motor. Okay, so I just hooked up the 6 pins to 6 of the ports on the Arduino. So I added a couple things. Here we have a button. It's actually detecting my button press. And while the button is being pressed, it's going to increase the PWM value, which is also directly hooked up to the motor's speed. So I can test out the motor right here, right now. I'm going to hit the button and it should slowly speed up. That's perfect. That's exactly what we want. This is great. This is exactly what I wanted. Okay, that's good. Test went well. We now have a spinning motor, which means that I'm now able to move on to step 2, which is 2 spinning motors. Okay, so I hooked up our second motor. If I hit the on switch now and test it, they should both move, which is exactly what happened. That's great, that's great, that's great. So great, we have 2 motors that can rotate, but like this whole pressing a physical button on the breadboard thing is getting kind of annoying. I would much rather just type in a command in my computer and then have it do that. The issue with that is if I want to get an exact speed, I'm not gonna know if the motors are actually going the speed that I want it to go, which is exactly where our closed loop control comes in that I talked about earlier. So to get proper closed loop control, we need to talk about these 6 cables coming out of our motor. We know that the red is positive power and the white is negative power because they're already hooked up to the motor controller. Now on the back here we have what's called an encoder, and this little black wheel is going to spin at the same speed as the drive shaft of the motor, and it's going to send some information about the speed and direction of the motor back to our Arduino. The black cable is a 5 volt ground, and then the blue cable is 5 volt power supply for the encoder. This and the motor require different voltages to actually work. Ooh, that's magnetic. The green and yellow are the 2 cables that will actually provide information. The green cable is going to provide direction information, and the yellow cable is going to provide speed information. So we need to hook all these up to the proper places on the Arduino for everything to work. Okay, so now I have the Arduino's 5 volts and ground running over to the blue and black of both motors. You'll see that there's a green light on both of these motors, which means the encoders are now actually powered on, and there are signals traveling through these yellow and green wires, which I'm going to hook up in a second. I connected all the wires together, made it very compact and neat. I'm going to demonstrate what the final outcome looks like. So we have our screen here. If I type in W120, and if I actually hit the switch, then we'll see both of these moving, and we'll see the actual data adjusting in real time. We can speed it up, 200, boom. We can stop it. We can go backwards as well. So backwards, we'll go 200. We can indeed come backwards. And then let's have them switch to turn now. So we'll go A 100. It should both slow down and they'll start going in different directions now. So this one is going that way, and then this one is coming this way. And we can flip it around, reverse the roles. They should both stop and go the other way now. There it is, closed loop dual motor control using our handy dandy Arduino Nano and an L298N motor controller. Okay, great, I can control 2 motors now using Arduino, and I have 2 sets of 2 wheels that are ready to be put into a Rover. So what's next? Well, I'm gonna need a central computer that can tell the Arduino Nanos exactly what to do. And that's gonna be a Raspberry Pi, which I already have, and I just need to program all the stuff to get that working. The other thing I'm going to need to do is build a chassis which can house all the components. Thank you so much for watching this video. If you liked it, please like it, and if you want to see me build out the rest of this rover, definitely subscribe and look out for the next video.